Hi everyone, let's discuss another Leetcode problem. Today's Leetcode problem is problem 198, house robber. So the problem says you are a professional robber planning to rob houses along a street. Each house a certain amount of money stashed. The only constraint that stop you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses are broken on the same night. So this is a constraint. I cannot, every house has some money in it, and I cannot rob adjacent houses. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So I know which house has how much money. So I have to be intelligent enough, and I should have very good algorithmic concept to make sure that I get the maximum amount of money, and I have to decide which houses I will rob without alerting the police. Okay, so the first example here, you see, is like 1, 2, 3, 1. Okay, so how can we rob these houses? Say we can rob 1, then we cannot rob 2, we can rob 3, right? So in that case, 1 and 3 is 4. Or we can rob 2. In that case, I cannot rob 3. So I can rob 4, house 4, and the amount is 3. Okay, so the maximum amount I can make is 4. So for that, the intelligent choices, I would rob house 1 and house 3. Okay, so let's look at the second example. This one was pretty easy to understand. For the second example, let's try to draw it. So we say we rob two. Okay, so we start from here. Let's draw it as a decision tree, because we have to take decision which house I want to rob and which I don't want to rob. So either I rob 2 or I rob 7, right? Okay, the first 2. If I rob 2, then I can rob, say, 9, right? And if I rob 7, I can rob, say, 3. Okay. And then if I rob 9, I can again rob 1. So in total, there will be like 12 from this branch. And if I rob 3, I cannot rob 1. Okay, so so the maximum amount is 12. But that's not all. Say if I rob 7, right? This is the second house. I could have robbed, say, 1 as well, right? Because it's not adjacent. Or if I had robbed, say, 2, this amount of money, I could also have robbed 3. Who knows, right? You never know. So this is only 5 elements. Let's see if there are like, so this is house 0. This is the beginning. This is, say, house 1. This is house 2. This is house 3. This is house 5. And this is house 4. Now the thing is, it might seem intuitive to try, say, house 1, 3, 5, right? Or try 4, 2, 4, 6, but it's not always the true. Let's give you one example. Say you have this 1, then 7, then say, okay, not 7. Let's say 7, 1, then 2, then I have this 11. Okay. Now see, if I just take house 1 and 3, and then I try 2 and 4, that's not wise decision for me. This way I will get 9. This way I'll get 12. Instead, if I just take, say, 7, and 11, right? These two will give me 18. And I'm not violating anything, and I'm not even alerting the police. So that means these connections also might be very helpful, right? Okay, so if you have like a large amount, like big array, and so many of these connections, right? This is going to be very difficult, and this might become an exponential thing. Okay. So can we do it easily? And the other thing that you see here is like we can actually solve, like this problem has optimal subproblem. So you can say like this. So 2, 7, 9, 3, 1. Can we say that my subproblem is I rob this and I rob plus max of this portion, right? Or I just rob, sorry. So can I say like max of, say, okay, let's say this is rob function will give me the highest. So can I say rob of 2, 7, 9, 3, 1 equals to either this or either this or rob of 7, 9, 3, 1. Can we say that? Of course, right? Either I rob house 1 or I don't rob it. So if I rob it, then I will try to get the max rob point from this portion. If I don't rob it, in that case, I will try to find the max rob from this whole thing, right? In that case, I will try to get the max rob, sorry, from this portion. That's exactly here. So you can see this problem can be equated as a optimal subproblem, right? Can be broken down into optimal subproblem. Okay, so in that case, let's try to do it like using dynamic programming, and we'll try this bottom-up approach. So let's say we'll try with 27931. 27931. 27931. Okay. So let's keep an array. Okay, so you see that for any house, say if I come here, like what are my choices? Or if I come here, there's, say this is nth house. So what is the maximum amount that I can make up until nth house? Can I say that I want to, and the constraint here says that all the houses have like positive amount of money. Now, can I say that I have two choices? The first choice is, hey, the first choice is like asking here, like max of this plus nth house. So can I say that max of until nth minus 2th house plus money of nth house, say nth house. So that's one option. Or I can just skip nth house. So let's write it like this. Rob nth. Or I can say, I don't want to rob nth. I have made so much money up until robbing this house. Can I say n minus 1? So like max of n minus 1, like how much money I've made till n minus 1, and 0, like don't rob, like 0. It's like don't rob nth house, because I cannot, if I want to take up to max of n minus 1, right? I cannot just rob my house, okay? So that way, if I take this array, we know that if I rob the first house, the max amount that I will have is going to be 2. This is if there were like only one house, I could maximum make two like $2 or something like that. Now for the third one, either I add 7 plus n minus 2. So let's put a 0 here. That means this is a dummy. So 7 plus 0, or I just don't rob this house. I don't rob this house. I just am satisfied with the previous one. Max of this. What is the max of this? It's 7, right? Okay. Next, I'm deciding here, like, should I rob this house or not? Okay, so how much I will make up until this house so either I rob this plus I take the max up to n minus 1,000. That means n plus 2. Or I don't rob this house and I am satisfied with just whatever was made up until my previous house. Okay, so what is that? That is, now it's 11, right? So 11 here. Next, about 3. So the max of 3 is going to be a max amount till this house is either I get like 7 plus 3, or I don't drop this house and I'm satisfied with 11. And obviously, I'm going to satisfied with 11, right? So up until this house, it's 11, right? Up until this house, it was also 11. Okay, so this is 11 actually, okay? Yep. Next, about this, like, should I rob or not? If I rob, and then I can take the max up to my previous 2 steps, so it will be 12. If I don't rob, I have to be happy with the max that I made up until the previous house, so that's 11. Okay, obviously 12 is greater, so I'll take 12. Okay, so in the bottom I've approached, and finally, this is our result. This is the last house that we got. So we can make maximum of 12 grand if I rob the houses intelligently. Okay, so let's try to code this. So we'll need the array to keep the result of the maximum amount earned till that point. So the array size is going to be a number of houses plus 1, because we are actually starting from the second house, and in our base case we are going to put the first 2. Okay, so max of 1 is going to be nums 0. Okay, this is the first house, and max of 0 equals to 0. That means no house has been robbed. Now I run a for loop from the second house till the last house. So the second house is actually an index of 1. And then I would calculate max of so maximum amount I can make up until the ith house is maximum of either I rob ith house, in that case is nums I minus 1 plus nums I Or let's make it say I plus 1. So second house, we just match the index with the house number. So I minus 1. Right? Or what I take is max of I. That means this is my previous house, the amount that I made, the highest amount I made up until till robbing my previous house, and this is previous house. Plus I robbed the current house. Okay, so finally what we do is we return max of sorry, this is the last house, max length. Okay, so this is accepted, and this was pretty fast. And you see that we have run this for loop just n times. So this is an order of n algorithm. Time complexity is order of n, and the space complexity is going to be, this is the amount of space we used, n plus 1. So the space complexity is also going to be order of n. Thanks for watching. We'll come back with another video.